right, so now we're going to go on to section 1.2, data sampling and variation in data and sampling. All right, so we have data can be categorized into two different categories, qualitative and quantitative. And in the last section, they called those categorical and numerical. Okay, these are interchangeable. You'll need to know both. The qualitative is the same as categorical, and quantitative is the same as numerical. Qualitative data are categories or describing attributes of the population, like hair color, ethnic group, the car drives, things that can be put into categories. Okay, or it describes a quality. So that makes it qualitative data. Now, quantitative, they are always numbers. Okay, they come from counting or measuring. And within qualitative data, we have two different types of that kind of data. We have discrete and continuous. Okay, so if it's quantitative data, we're going to say that it's either going to be discrete quantitative or continuous quantitative. All right, so we're going to use this flowchart to kind of go through some different examples and talk about what kind of data it is. So data can be either qualitative or quantitative. Remember, qualitative, it's categories or describing, and quantitative is always numbers. And if it's quantitative, we need to decide if it's going to be discrete or continuous. So let's talk about the distance the nearest grocery store is from your home. Distance is a number, okay, so that makes it quantitative. Now, if we know that distance is a number and it's quantitative, now we just need to decide, is it discrete or continuous? Distance is not counting, distance is measuring. So the distance that the nearest grocery store is away from your house is going to be continuous, a quantitative continuous measurement. All right, let's try another one. So let's do political party affiliations. Okay, so a political party would be like Democrat, Republican, Libertarian, Constitutionalist, all of those kind of things. Now, those are categories or words, so that makes this qualitative. There aren't any numbers involved with your affiliation for political preferences. Okay? So that makes that qualitative. Now let's talk about the classes that you're going to take this school year. What classes are you going to take this school year? So this one, is it going to be a number or is it categories or describing? So the classes you're going to take, whether it's going to be art, choir, jazz band, athletic training, that kind of stuff, those are categories. And then if it's going to, if I said, how many classes are you going to take? That's a number, so that makes it quantitative. And it's a discrete one because you can count them. So you're counting the number of classes. All right, so now we're going to go to page 15 and talk about qualitative data. So there are lots of different ways that you can display qualitative data. Frequency tables are one of the ones that Snow College is going to ask you to prepare. There are also pie charts, bar graphs, Pareto table or Pareto chart, but most of what you're going to need to know for Snow College is going to be frequency tables. Okay? And a frequency table is just that. It tells you how frequently that occurs. All right, so we're going to jump to page 17. So frequencies, if they don't add up to the total number of students, that means that you need to create a bar graph, not a pie chart, because pie charts are always out of 100%. So you need to make sure that if you are using that to display your data, that you have 100%, and your frequencies add up to the total number of students. All right, so taking a look at this, we've got our frequency and then the percent. And you'll see our total doesn't add up to the total number of students. We only have 90.4% out of the 100%. Okay? Now, the way that we can deal with that is by adding an other category. So we would put one more in here before our total as other. And once we've added that in, then we will have our 100%. So for the ethnicity of students, we have all of the ones from our frequency table, and then we have our other or unknown category. All right, so now we're going to go to page 19, talk about sampling. A sample needs to have the same characteristics as the population that it is supposed to represent. The way we do this is random sampling or a simple random sample. Okay, the simple random sample is basically like you're throwing names into a hat, you shake it up, and you pull out that name. This is done with replacement. So you pull that name out and you put it back in. That is what a true random sample is. But there are different ways that we can talk about sampling. Okay, other methods of random sampling are stratified, cluster, and systematic. Okay, so we can do, instead of always having to write something on a piece of paper and put it in a hat, we can use the calculators to do a random sample. Okay, and the instructions are up here on page 20. Okay, so you hit math, go to probability, and we're going to enter from 0 to 30, and we want the first random number. Okay, so every time you do it, it's basically choosing that number out of that interval. So from 0 to 30, and the first one it chose was 29. Then it puts that number 29 back in, and you can get 28. Okay, so this is how you can use your calculator to do a random sample. All right, so let's go back down to the other methods. A stratified sample is when we put them into groups called strata, and then we take a proportionate number from each stratum. Okay, so we're going to take the same or proportionate amount from each group. All right, and we'll go through an example on this in a minute. Then we have cluster sampling, which means we're dividing it into clusters, and then we randomly select one of the clusters, and then this is the key word. All from that cluster get selected. Okay, so all from one cluster gets selected. Then you have a systematic sample where we randomly select a starting point and we take every nth piece of data. So let's say I randomly select that I am going to start with the 14th person, and that then after that point I'm going to choose every 5th person. Okay, so every 5th person after that it's to be randomly select. Then we have convenience sampling. This happens most often because it is available. Okay? So convenience sample is one of the worst ways to sample, but it's one that gets the most. It is readily available. Okay, so it's better right here. It's better for the person conducting the survey to select the sample respondents. Okay, to have this, you can have a lot of bias involved with a convenient sample. Sometimes you can end up with good data, but a lot of times we want to avoid convenient sampling if possible, and use one of the other methods of sampling. Okay, true sample is placement, but in real life, practical life, most of it's done without replacement. Okay, so most of it's without replacement. Let's talk about with replacement and replacement. With replacement means that sample put back in. So if it's 1,000 out of 10,000, then I put that back in. Okay, and without replacement means that when I draw that out, the options and the total both decrease. Okay, so that's without replacement. Okay, and then we have that happen with sampling. We have some errors that come from actual process of sampling. If it's an error caused by anything that's not a part of the sampling process, that's a non-sample error. So, for example, if your counting device fouls up, that's a sampling error. A sample bias, something that's created when it's collected from a population, and some of the population are not as likely to be chosen as others in that population. Okay. Sampling bias, when you have that occurring, not everyone's equally likely to be. All right, so this is on page 22, the try it number 1.11. And this is a bunch of data. It's already be kind of nicely organized for us, but we're going to do each kind of sampling. So we're going to start with the random sample. So this would be like putting all of these into a hat and then randomly selecting them out. Okay, that's the one that almost everybody is more comfortable with. So let's talk about stratified. So a stratified sample means we cut it into strata. This is like our group 1, group 2, 3, 4, 5, and 6, those columns. Okay, so if I'm going to do a stratified sample, let's say that I'm going to randomly select 3 from each strata. That means I select 3 random ones from the first strata, 3 random ones from the second strata, and 3 from the third strata, and so forth, so that there's equal representation from all of the strata or all the groups. Okay, so that's stratified. Now if we talk about cluster sampling, a cluster means that I've got these into groups and I can still use these columns as my groups or my clusters, but instead of taking the same number from each one, so each one is represented, I'm going to randomly select one of the clusters, and let's say I randomly select number 4. Then that means all of those points, those data points, are selected. That's how cluster works. You divide them into clusters, and then you randomly select one of the clusters, and everything that's in that cluster gets selected for your sample. Then you can do a systematic. Systematic says, okay, I'm going to randomly choose a starting point. So let's say I randomly choose, and my starting point is right here. And then I'm going to take every 7th number. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I choose 4. 1, 2, 3, 4, 5, 6, 7. I choose 7. And you keep going through that and selecting all of the 7th numbers. So that's how systematic works. All right, so now we're going to start leading into variation. So if we're to examine 2 samples representing the same population, even if we used random sampling methods, the samples will not be exactly the same. So just as there is variation in data, there's variation in samples. So we will always have variation. All right, so on the bottom of page 25, variation is always going to be present in any set of data. So we know that pop cans, like this one, okay, here's my pop can, says it's supposed to have 12 fluid ounces. Now if I actually go through and measure this, it can be off a little bit. It might have more, it might have less. Okay, so we're going to use this one as an example, but they've got our data here. So it's talking about 16-ounce cans instead of a 12-ounce can. So these are ones that were actually measured, and do you see the variation? Okay, so if they're supposed to have 16 ounces, this one has less, a little more, a little less, less. Do you see how we're going to get variation in our data? Okay, and we'll always have variation. That's part of sampling. That's part of data. Hey, and another thing to talk about is the size of a sample, or the number of observations. This is very important. Okay? If you only have a in your sample, your data may not be data. Okay? You want to have a larger the sample, so you can have a better representation of population. And just because you have a large sample doesn't mean that it's biased. So somebody says, yeah, we see 100,000 people. They could still have bias. Okay? So the great example is a survey. Almost always biased because the people are choosing whether or not they want font. All right, so let's talk about some problems that we have with sampling. We need to make sure that some of the problems that happen is that the sample is not representative of the population. It's biased. Okay? It's not representation. Self-selected samples. People are choosing to respond, like call-in surveys. Self-selected sample has issues. Size. Maybe not selecting enough. You're not sampling enough. Undue influence. So the way that the questions are no response or refusal of a subject to praise. So if people have the choice of not to, that can affect and bias into your sampling. Okay? Causality. Okay, this is the big one in statistics. You can have a relationship or relation between two things, but that doesn't mean that one is the other. Okay, so just because you can say that there's a relation does not mean that it causes. Self-fund or self-interest studies. So let's say you own a company and you want to study the same thing that you're building, creating, and you're doing self-funded, self-interested study. Okay? And usually it will lead to bias. Okay, misleading use of data. Improperly displaying graphs or using complete data or not putting it into context. Okay, so using data to mislead. Confounding. That's when the effects of multiple factors on a response cannot be separated, meaning there are things that are happening that you can't isolate, you can't take out of the situation. So some confounding might happen, and that will affect your data. All right, so that's the rundown on sampling techniques and talking about issues that can happen with the sample.